communicate with the cloud platforms. So this is the basic difference.
Okay, thank you, sir.
Okay. Now I will discuss the features of this test IoT. So first of all, I will go in the sequence. So it has a 12-volt power jack. Using you can power this entire board. So you do not have to connect externally batteries and everything. You just have to connect an adapter, and your board will get powered up. After that, we have this reset switch to suppose some problem happens in the programming, your microcontroller gets stuck somewhere, then you can just press this reset button and it will start from the beginning. After that, we have provided two LEDs for the testing purpose. In case of you need in your application, or if you need any LEDs in your testing, you can use these LEDs. So LED input is there provided. You can see LED 1 is there, LED 2 is there. Just you have to use GPIO pins and connect it with the LED inputs, and you can access these LEDs. After that, we have this ESP8266 chip. It comes with the Wi-Fi capabilities and built-in Wi-Fi stack, TCP/IP stack, trans transmission control protocol. After that, we have provided onboard LDR sensor, which is light-dependent resistor, using which we can measure the intensity of light. So we have provided this sensor on the board. After that, you can see the output is provided here. So you can take a jumper wire, connect it with here light output, and then connect it with the analog input here. You can see ADC 0, and you can read the data from this sensor into microcontroller. After that, we have provided this NTC thermistor sensor, which is 10K, and using this sensor, you can measure the temperature. After that, we have provided the pull-ups. You can see register network is there. Whenever you are near, we are going to need any pull-ups in the circuit, you can use just you have use the jumper man and you can connect it to your circuit. After that, very important part is whenever you want to do any IoT project, uh, important thing is you want to control some actuators, like suppose the project is home automation. In that case, you want to control some fan, tubes, TV, any appliances, AC appliance. In that case, you will need relays. So using these direct relays, you can just switch on and off, use your appliances, electrical appliances, from the cloud. So these relay modules are provided, using you can control the appliances. After that, a buzzer is provided. So in some cases, in some application, if you need any buzzer, you can use this buzzer. You can see here the buzzer input is here. You just have to use the jumper wire here to here. Buzzer. After that, we have provided another sensor. The board includes a total of three sensors: the LDR, thermistor, and the third sensor is Hall effect sensor. Hall effect sensor is used to measure the intensity of magnetic field. So Hall effect sensor is provided. So in many applications, you can use the Hall effect sensor. After that, we have provided voltage divider, because the ESP8266 chip runs on 3.3 volt. So in cases if you want to interface something which is higher in voltage or the potential difference, in that case what you can do, you can just uh, connect that higher output with this 5 volt pin, and then you will get 3.3 voltage output here. So we have provided some voltage divider as well here. After that, motor driver is provided up to 1.5 amperes of current capacity, and you can interface 12 volt of motor here on this connection. So using IoT or the Android application, you can control the speed of motor, DC motor, or you can turn it on, turn it off using this motor driver. After that, we have power sources. You can see the ground is there, 5 volt is there, 12 volt is there. So you can take the power sources as per your requirement in the circuit or your application. Also, here we have provided the 3.3 volt power sources. After that, we have preset. So in some cases, suppose I want to control the speed of this motor using this pot, this preset. So this is a 10K preset. You just have to connect a jumper wire here, analog output you can see, and connect it with the analog pin of microcontroller or the ESP8266. We can read the data of this preset, and we can vary the voltage on this ADC pin, and according to that we can control the speed of this motor using PWM. Total of 4 PWMs are provided. 4 PWM pins are available on this module. So you can control the 4 PWM channels. After that, we have this LCD setup, using which you can directly interface the LCD module here. You can see, and then you just have to connect few jumper wires. I think 6 jumper wires you have to connect to print characters on the LCD display. I will show you. So here you can see we have interfaced a LCD. It sits like this on the board. You just have to plug it on this board. After that, we have GPIO pins. You can see all these are GPIO pins, general purpose input output. Using these pins, you can connect with the actuators. You can take inputs, you can do output, you can do anything. But only drawback of this ESP8266 chip is that it has only one analog input pin. So there are no multiple analog input pins. In that case, you have to use I2C protocol or the I2C module to read the sensors of different analog sensors. So that is one of the drawbacks which this chip has. It only has one analog input. Then we have very important micro USB port. Using this port, you can directly connect this board with the computer or laptop or PC, and you can directly ready for programming of this board. So these all are the features of Tesla IoT board. What I will do, I will just try to show you this board in real time. I'll just open my camera. Hope I'm visible. So you can see it is in my hands. Is it visible?
Yes, yes.
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 So this is the Tesla IoT
Yes.
board, and throughout the session, I'm going to use this board itself. So we are going to do many applications. We'll start with the basic applications, and then we will go for the advanced applications.
Yes.
So first of all, we will start with the programming platforms, using which programming platforms you can program this Tesla IoT board. First of all, I will discuss about the uh, built-in firmware which comes in whenever you
Hello.
buy. Hello.
Hello. Hello,
Yes.
sir. In the ESP32 has the analog pin also more, and it has also a Hall
Yes.
effect sensor. Then why
Yes.
you had not used ESP32?
Ma'am, we are going to make another board. We are in the process of manufacturing of that board, which comes with the ESP32. What we done, we have created different versions of this board because from price point of view, everybody cannot afford the different prices or the expensive boards. That is the reason first we have created this inexpensive board, which every student can afford or the every professor can afford. So that is the reason we have used this chip, because ESP32 is expensive, as you know also. So we are going to make that board also. Is it okay, ma'am?
Sir, my question is simple.
Okay.
But sir, ESP32 and ESP8266 price is almost nearest, not?
Uh, no, madam. This chip is almost ESP8266 will cost you around 130 or 150 rupees. It depends upon the vendor. And if you want to buy ESP32 chip only, not the
Yeah,
module, it will.
500 or 600.
Yes, yes. So that
Sir,
is the
this board
difference.
is really useful to students as well as faculties to develop projects.
Yes.
Sir, my question is why it is named as Tesla IoT?
See, as I am a beginner startup, it is very new in the market. So I wanted to give a simple name which everybody knows, and it is very famous in the technological field, like Tesla car, Tesla scientist is there. So many things are there, and he's very famous. This name is very famous. So people should remember this name along with this Tesla IoT board. That is the reason I have given this name.
Okay.
And sir, one more thing, reset button is also included in the ESP8266 mode. Then why you had differentiate in the Tesla mode reset button?
Oh, I did not understand. What is your question?
I'm saying that that reset mode RST button is involved in the ESP8266. Then why you had kept different in this Tesla mode reset switches?
Madam, there is no button available on the chip. You can see here. There are two methods using. You can reset the microcontroller, this ESP8266 using software, the reset function, and the using a physical button on the reset pin. There is no button which is pre-built on this Wi-Fi chip. You can see it clearly.
Okay.
Yes.
Sir, it is commercially available in the market?
Yes. We have started the manufacturing. We have started the selling of this product as well. At the end of these sessions, I'm going to discuss about this commercial point of view.
Okay.
Also, for this Tesla IoT board,
Sir,
we are yes.
why you would require 12-volt power jack?
So basically, adapters in the market are available in the 9 volt, 12 volt. You can just plug it in. Okay, we have provided here the regulator for 5 volt and 3 volt. 3 volt regulator on the other side of the PCB, so you will be not able to see that. But using regulators, we have regulated that voltage to 3.3 volt.
Okay.
Yes. So for this board, also, Tesla IoT board, we also provide the training. Also, whenever you buy, we provide the online training. So I will discuss about all this at the end of the session. Now I will discuss what are the methods using which you can program this ESP8266 chip or the Tesla IoT board. In fact, so first of all, whenever you buy any Wi-Fi model, ESP8266 model, it comes with the built-in firmware, which is called as AT commands. Using AT commands, you can give serially commands to this chip. I will just show you AT commands for ESP8266. You can see. So whenever you are using AT commands, you have to use a software which can be a putty or termite. Different softwares are available using which you can serially, and using UART protocol, you can communicate with the model. So these are the commands you have to type. I will just open the putty. I will show you. Will not have putty. I will termite. Yes, I have termite. So using these commands, you can connect to the Wi-Fi model. You can see here Wi-Fi mode, different modes are available in the system, STA, access point. So this is the software you can see. This software. So in the settings, you have to select the port to which port you have connected this Wi-Fi module or the Tesla IoT board. You have to select the correct port. I'm going to show you how to select the correct port, and after that you have to just set the baud rate and all these things, and then you are ready to communicate with the Tesla IoT board. And here you have to type the AT commands. Right now, I don't have the AT firmware. I'm just discussing the various platforms or the various methods using which you can communicate with the Tesla IoT board, or you can program it. The first is termite or the AT commands. You can just go through these commands, or the how you can program ESP8266 using AT commands. You can just search it and you can read it through. After that, we have Visual Studio. Similar to Arduino IDE software, we have Visual Studio software, which is by Microsoft, using which you can program You just have to install it. You have to add the plugin for ESP8266 and you're ready to go. You can just program it in C. Another method is Mongoose OS is there. OS is there. It is a real time. It is RTC. Using this Mongoose OS, you can see Mongoose OS device. I will just click on learn more. So it supports the ESP32 and the ESP8266. You can communicate with the different cloud platforms. So another method is these methods are very advanced and used in the industries. So you can connect using this Mongoose OS with the AWS IoT, Azure Cloud Platform IoT Core. Okay, so Mongoose OS is there. If you want to learn more about this, you can just go through the documentation of this Mongoose OS. You can watch the videos and you can just click on this part. AWS IoT on Mongoose OS part 1, ESP8266 and 32. This is another method. And the very famous among the students and the enthusiasts, which is Arduino IDE. And it is, I will also recommend if you are a beginner or you want to do projects very easily, just go with the Arduino IDE. Just I will type Arduino. I will start with the basics. So how you can download the software? Just type the Arduino IDE, go to Arduino. In the software, you'll see lots of options are available. Depending upon your operating system, just select one and click on it. So I will select Windows 7 or newer because I'm using system on Windows machine. Just download and then download will start. I will pause it, cancel, because I already have downloaded it and installed it. You just have to follow the steps. You have to click next and it will get installed. No big deal. And after that you'll see icon available on your desktop. I'll show you in the middle this Arduino IDE. Now
This Arduino IDE is open source.
yes, it is open source. It is freely available and lot of resources are also available with the Arduino IDE. So I will just open the software. And then I will click new and close the previous file. You can see whenever you open or the starting this software for the first time, it will show the similar interface like this. It will come with the default code of blocks. You can see the void setup will be there and the void loop is there. So this is the structure of programming using Arduino IDE. So whenever you are programming any module like Arduino Uno is there, Arduino Mega is there, Nano is there, ESP8266 is there. Any device, if you want to program using the using Arduino IDE, you have to program it in this fashion using these blocks, these code blocks. So inside this void setup, you have to write the configuration related to the program, and the main code program you have to write inside the void loop. So whatever the code you have put inside this void setup, it will run or it will execute only for once, and whatever code the program you have written inside the void loop, it will run forever, and until and unless you cut the power for the module Tesla or the any other module, it will run forever. So what I will do, first thing, we have seen how to download this Arduino IDE. After that, how we can program Tesla IoT board using this Arduino IDE. First of all, so I will just open the PPT. I will go here. Now we discussed the programming methods. Now I'll discuss the how we can install this CS340G driver, which is required for communication. So what I will do, I will just connect the Tesla IoT board with my laptop. You just have to plug the micro USB cable like this. And now you have to select the COM port available here. See, COM port 8, lots of ports are showing here, but how to select which port is correct and to which port we have connected this, how to identify that, we'll discuss that first. To do that, first of all, just press the button as Windows and X. Press the button as Windows and X, or just simply type here device manager, and click here. And after that, go to ports, and here you will find this USB serial CH340G 340. It is connected to COM port 8, but before you install this software, which is this driver, it will not show the device manager because I already have installed the driver. That is the reason this port is available here. In your case, if you have not installed it previously, it will not show the port or the Tesla board that you have connected with your PC. So first thing, whenever you are connecting Tesla board with the computer, first you install the CH340 driver. I will show you how you can install it. Just type CH40G driver and click hit enter. Then open this first link sparks.goo and click. So you see CH340 drivers for Windows, Mac and Linux. So this driver is basically used for communication medium between the Tesla IoT board and the computer. Without this driver, we will not be available to communicate with it. So for Windows machine, just click here, Windows CH340 driver, click on it. So it will download a zip file. I will open it, showing folder, and then see, I already have downloaded it and installed it. That is the reason it was showing the port. So I will just unzip it here. To unzip it, right click on it and click on extract to this folder, and after that open this folder and double click on it and then click yes. So I already have installed, that is the reason I will not install it again, or I will just simply reinstall it, no problem. First I will uninstall it. Okay, now I will check if it does shows the port or not. So see, I uninstall. As soon as I uninstall, the port is not visible anymore here. You can see here the COM port 8 is not visible. Now what I will do, I will install it. Driver install success. That's it. It will take only few minutes to install this driver. Now I will again open the device manager. Now again this will show the USB serial, this COM port available COM port. So using this COM port, we can now program the Tesla IoT board. Now we have finished the installation of driver. I will close this. Just I will repeat the process first. Just type the CH340G driver and open the first link which shows the sparks.google. Click on it and just click this link, Windows CH340G driver. It will download the zip, extract it and install it. That's it. After that, what we will do? See, it is visible now. Now I will again open the software. So whenever you are doing, suppose assume that I'm doing this all things, assuming that you are doing this for the first time. So all these steps are required to do whenever you are installing the new software or you are doing it for the first time. So remember, all these steps are important. After this, whenever we have installed the software, now we have installed the driver. Now it is important to install ESP8266 board on the software, because whenever you install the Arduino for the first time, it will not come with pre-built modules available. So it will have only this Arduino boards available. You can see Arduino AVR boards available. As I already have installed the ESP board, that is the reason it is showing this board. So what I will do, I will uninstall it, and then I will show you how you can install the ESP boards. So just type ESP and I will click remove. Now you can see only Arduino board is available. No other board is available. So whenever you install for the first time, it will look like this. It will not come up with the Wi-Fi modules or the ESP modules pre-built available on this software. So to use Tesla board or the ESP8266 using this software or to program, we have to install these boards on the software. So how we can do that? First, we have to open Google and just type ESP8266 and click is Arduino master. And open this link now. See this link, Arduino ESP. Later I will provide all these required link on the WhatsApp group. Don't worry if you miss this. So just click on it, and then you can see installing board manager using. Start the Arduino and open preferences window. We have already opened the preferences window here. From here, go to files and open the preferences. And you can see all the links I already have pasted so that it will show. So by default it will look like this: additional board manager URLs. Then simply copy this link, Control C, and paste it here. Unless and until you paste this URL here, you will not be able to find the board ESP8266 board available in the board manager. Okay, so if you do not paste that link in the preferences, even if you search here ESP, the ESP board will not show. I'll just quickly show you that. So it is very important to add the link. I'll Control A. I'll just remove that link, and then I can go to Tools, Board Manager, and now I'll type ESP. Now it will not show any ESP boards available. See, so it is very important to paste that link so the software can know from where to download these boards. Okay, now I will install it. I'll change the version to 2.5.2. I'm installing a old version. I'll discuss the reason behind it when we are connecting the Tesla board with the Firebase. In that case, I will discuss why I have selected the olden version of this ESP8266. Now we have installed it. Now the boards are available here again in the software. You can see. Then select this module, Node MCU 1.0 ESP12E module. Select this one because we are using 12E chip. Okay, we have selected this. Now what is the COM port? So how to select the right COM port? After everything is done, we have to select using which port, using which USB port you are communicating or programming the Tesla IoT board. So you have to select the correct port here. To select the correct port, again, I will open the device manager. We also know this is the COM port 5, but in case if it shows some another name, how we can know? So I will just unplug the Tesla IoT board. I have unplugged it. Now the name is not visible anymore, CH340G. I will plug it again, Tesla IoT board. Now see, USB serial CH340 COM, it is connected to COM port 5. So that means our Tesla board is connected to COM port 5. We have to select this port now.
Hello? Hello?
Yes, ma'am.
Yes, sir. Sir, sometimes it's showing the error like comport is not free or comport is not available. What?
So whenever you are connecting Arduino or any other module with the COM port and you have your open any session on that port, so like serial communication is there or the you have open the serial monitor on that particular port, in that case it will show that error. So whenever you are trying to communicate, just close any sessions which are live and then you can then communicate with it, so you can eliminate that error. So we have selected the port, we have selected the correct board, which is Node MCU, and then we'll just see everything is correct or not. Just hit compile button. Using this compile button, it will compile this code, which is blank, and it will check for any possible errors. So we will wait for some time. So it shows done compiling. It means everything is correct setup. Now after
So,
that,
so
yes.
what is the significance of the different baud rates in the serial port?
See, baud rates are nothing but data communication rate of the speed. Bits per second is nothing but baud rate. So different baud rates are available. You can see here upload speed. This is upload speed. You can select any other speed as well. This is upload speed, and the baud rate is whenever you are doing some serial communication protocol. For example, in case of Arduino, I have to set it like serial dot begin to initialize the serial module, serial begin, and inside it I have to provide the baud rate. So you can provide any baud rate you like, but make sure that your system, your computer or Tesla board are running on the same baud rate so that they communicate. If you setting this baud rate like 9600 here and you're trying to communicate from serial monitor using this baud rate, so it will not communicate with the Tesla IoT board or any other board. So make sure that all the modules which are communicating with each other using serial or the UART protocol, they are on the same baud rate or the same data transmission rate. So that is the significance of baud rate.
Hello, sir. Sir, how
Yes,
can we know our computer is working on which bandwidth?
bandwidth, baud rate.
Yeah. How can we know that my computer is working on which bandwidth? So for that I had set this bandwidth.
Yes, ma'am. Using different softwares, you can communicate with this Tesla IoT board or ESP8266, like Termite I have shown. Using a pre-built serial communication software, serial monitor on the Arduino, you can check. You can see here, you can select the different baud rates available, starting from 300, 1200, like this. So you have to select here whatever you have programmed baud rate into Tesla IoT board or any other chip, you have to select that only here. So you do not have to identify, you just have to select the correct baud rate here also. So
Yes,
while
sir. Yes, sir. Sir, one time I had used ESP32. At that time, I had used with the ultrasonic sensor. For that, I need this serial monitor. So I had set my bandwidth at the 9600. So then it is working properly, no problem. After that, from both, I had changed from both from the serial monitor also and in the code also. Next time I had changed 11 to 50 something, but after that I had changed to this too many bandwidth, but it is not working on that. Why? Only working in two bandwidth. First one is 9600 and next one is 11 something bandwidth, 11250 something bandwidth. But it's not working on 300 bandwidth, or it's not working on 1200 bandwidth.
See,
Why?
there are two possibilities for that. First one is just I have discussed is make sure that all the models or the two models using your protocol you can communicate using two models only. Means one master will be there or slave will be there and vice versa. Only two models can communicate using your protocol. Make sure that they are all, both are on same baud rate. Second thing, first problem can be that. Second problem, you must have that hardware support on that chip for this baud rate. So your chip may not be able to sustain or may not have capabilities for higher baud rates. It depends upon hardware as well. So that is the reason. So just adjust your baud rate to lower bauds and check with that if it is work or not.
Means my ESP32 working on that bandwidth that I need to set here. Is that?
Means
Means on which bandwidth the ESP32 is working, that bandwidth I need to specify here. Is that?
yes.
Okay. Thank you. Got it.
Yes. So you make sure that every time both the devices are on the same baud rate. After that, what we will do? We will do our first program. I'll open the PPT. You can see the blink is there. So we'll do our first program here. So to run this first program, just go to files, go to examples and basics, and you will find this blink. I'll close this previous file. And this is the code which comes in the example files. You do not have to write anything. Now only thing I will change here, I will change this default LED pin. I will explain the code, don't worry. I will make it 5. Here also 5. Just I will explain the code. So I have already discussed that this block of code void setup only run or only execute for the one time, and whatever code you have included in the void loop, it will run for the forever, hence in infinite loop, because it is a void loop. So this pin mode, using this function, we can set a particular pin on Tesla IoT board. Its functionality means we can set that particular pin as an output or input. So using this function, you can set a particular pin to output or input. In our case, we want to blink LED now. So in case of LED blinking, we are taking output from that pin and connecting with the LED. But in case of switch interfacing, means we want to interface a switch or any digital sensor which gives output as an high or low, 1 0. So in that case, we have to make sure that we are making that particular pin as input. Input like this. So whenever you are taking some input from the sensor or the switch, make sure that that particular pin is in input mode, and whenever you are giving some output from the ESP8266 from the microcontroller, it should be output. So in case of LED blinking, it should be output. After that, in the void loop, we are using total of two functions. First is digital write and second is delay. Delay is used to generate a delay. Whatever argument you provide, it will take it as milliseconds. So 1000 milliseconds means 1 second. So it will stop for 1 second and then it will execute this line. Again, it will stop for 1 second. Then again, it will execute this first line and like that, so on. So first argument to pin mode, you can see here is pin number. You have to provide the pin number. I'll show you on the PPT. So you can see different pin numbers are provided here. So GP1 is there, GP2, 3 is there, 5 is there, 4 is there, 0 is there, 2 is there, 15 is there. See, all these numbers are nothing but GPIO numbers. GP means GPIO. So we have to select a digital pin and then we have to write it down as first argument here. The first argument for this function is pin and second is functionality. It's functionality, output or input. So it is output. In case of digital write, it will write the digital data on that particular pin. The first argument will be that pin number and second argument will be high or low. Means whatever data you are writing, means you are writing 1 or 0. 1 means high, low means 0. Again, high means 5 volt or 3.3 volt, whatever the voltage, higher voltage available for the microcontroller, and the low means 0, like that. So what I will do, I have changed the pin numbers and again I'll check for the, we have selected the correct board and the COM port as well, and then I will just upload it. So it will start uploading code. I'll open the software. So it is writing the code, you can see 33%, 41%, 50%, like that. And the 100%. Now what I will do, I will connect 5 number GPIO 5 with the LED. So I have connected this 5 number P with the LED. You can see the LED is blinking now with the 1 second of delay. If I change, I just take that output and connect it with the buzzer. So it will make sound like this for 1 second of delay. And if I connect this output again with the relay, you can see the relay sound. The relay is turning on and off. I'll just blow the another LED. So for just experiment, what we'll do, we'll change this delay. I'll make it 100 milliseconds. I want to blink this LED even faster. You can see now LED is glowing even faster. You can see here like this. If I change it to buzzer, you will hear the buzzer sound like this. So using Tesla IoT board, you can easily do any project like within minutes. This is very simple, I know, but with practice, you can do any IoT project within minutes. Now, after blink, what I will do, there are different simple projects are remaining, but we have less time. We have to finish like on 11:45. So what I will do, I will just skip these two programs. They are very easy, and we'll start with the Firebase part. So you have seen how to install this board into Arduino IDE. Just a minute. You have seen how to install this board using board manager. You have to add the link into preferences and then go to board manager and install this particular board and then select it. After that, we have seen how to select the correct COM port. We have to install the driver CH340 and then we can be able to select this port. After all this, we want to send whatever the data, sensor data is there, any digital data, serial data available, whatever data you have on the Tesla IoT board, you want to send that data into Firebase, any cloud platform. I'm particularly discussing about the Firebase now. In that case, how we can do that? So I will just discuss that. First thing, we need to have some prerequisites, like we have to install some libraries into this Arduino IDE for that, so that it can communicate with the Firebase. So first library is, you have to download it from the Google. So just type Arduino Firebase master and just click on the first link which is available, this Firebase, and then download this zip. Click on this code and just download zip. After that, go to again Arduino software, go to Sketch and include library, and here just have to click on add zip library. So I'll just check where I have downloaded it. It is in downloads. So Arduino Firebase Arduino master, you have to select it. It will show, in my case, it will show library is already installed, something like this. See, the library named Firebase Arduino master already exists because I already have installed. But in your case, it will show library added. Okay, something like that. So you have to download it and include it using library manager from Sketch. Second thing, go to Sketch again, and in this case, click on Manage Libraries. And type JSON. Scroll down and select this library, Arduino JSON by Benoit. You can see this particular library we have to install, Arduino JSON by Benoit, and select the version as 5.13.2. Why this particular version? I will discuss that. 5.13.2 and click install. So whenever you are working with the Firebase platform, you must have this library installed with this particular version, because the libraries are written for this particular version support. Okay, so latest version of Arduino JSON library will not support the libraries just we have included. So it will give some error. If you want to try, you can just update it and you can check. It will give you compilation error. So particularly whenever you are working with the Firebase platform with this library, use this 5.13.2. And in case of board, I previously discussed that why I have installed this 2.5.2 and not the latest one available. But the reason for it is that the board version also will not support the Firebase platform. Latest board version, which is 3.0.2 something, will not support the latest. This board will not support the Firebase latest version of this, but this version, the older version, will support it. That is the reason I have installed this 2.5. So we can just experiment with it. You can install the latest version and then check with it. After that, we have configured everything we need. Then whenever you add this library, Arduino Firebase Master, Firebase Arduino Master, it will show library added, and then go to examples and you will find here Firebase Arduino. See, whenever you include that library, the library which we have downloaded from the Google, it will show this example, and from this example just select this demo. This demo. Okay, now what I will do, I'll just hit compile to check everything is correct and we have configured everything right. So whatever the dependencies or the libraries are required, if we have installed them correctly, it will show compilation done, or it will give some errors. While it is compiling, then compiling. So everything is correct now. I'll just check the board is selected. Yes. After this, we have to configure the Firebase. Just type Firebase. And click here, this link. And after that, go to console. So various projects we have created already. So I'll show you how to create a new project. In your case, you have to create new project. Add project, you have to provide the name. So I will just type IoT DP and continue. In our project, we are going to not use this analytics and all. So I'll just disable it and just hit create project. After that, it will show your new project is ready, continue. After creating new project, you have to create a real-time database. For that, you have to go to build, here in build, and in build you will find the real-time database here. Click on it. And then click here, create database. Just select the US Central as default and click next. And click here, start in test mode. So it will take some time. Our database is created. Now to connect our Tesla IoT board with the Firebase, we are going to need some credentials. You can see these 4 credentials we have to provide. Among these two credentials we have with us, like Wi-Fi SSID and the password. So you can set it like if you have Wi-Fi set up in your campus or at your home, or even if you can provide the hotspot credentials of your mobile phone here. So in my case, I will be using my mobile phone's hotspot as Wi-Fi SSID. So it is project, and the password is computer12345. In your case, it can be different. So just check with it and write the correct SSID and password. 12345. After that, we have to provide Firebase host and Firebase auth for authentication. So this is Firebase host. Just copy it, Control C, and provide it here. Make sure that the end slash, the forward slash, and the first this part you have to remove it, and just have to paste the pure link here. Just have to remove the HTTPS part and the forward slashes. Make sure that you have removed it. If you don't remove it, you will not be able to connect with the Firebase. After that, we'll need this authentication, this key, database secret key. For that, we have to go to settings, project settings, and service accounts. Click here on service accounts, and then click here database secrets. And simply copy it. I'll just copy it. Control V, and everything is set. We just have to upload this code with the correct COM port, and COM port, I think in our case it was COM port 5. I'll again open it. So whenever we are sending any data from the Tesla ID board, it will appear on this console under this tree. So I'll just check one thing for server authentication, and then we'll upload the code. This fingerprint for server authentication, it makes sure that our data is going to the authenticated Google servers, means that there is no breach and our data is safe. So it just makes sure that we are communicating with the Google's server. So it is optional, it is not mandatory. That is the reason I have done it fast. I'm just checking if it is correct or not. So it is old one. So make sure that you are updating it with the close. Now I will upload our code. Sorry, I am not connected. Now I have connected the Tesla board. Select the COM port. Correct COM port is COM port 5, and then just hit upload. As soon as our code will get uploaded, it will start updating this 42 number and some random numbers. I will make sure that I'm turning on my mobile phone's hotspot. I have turned on with these credentials, project and computer 12345, and the baud rate is 9600. Open the Firebase. Now you can see we are sending data from the Tesla board to the cloud. From the Tesla board to the cloud. So this data on serial monitor you are seeing is going to the cloud using this. It is connected with my mobile hotspot and it is sending the data over the internet towards this cloud. Firebase. Now what we will do? We'll do some experiments. So this is just data communication. I'm sending some random data on the Firebase. But what if I want to control the LED or the buzzer or any component or any peripheral available on the Tesla board from the cloud? Means whenever I type something or do something on the cloud, I want to see some action going on here. So we will do that. I have written code already, so I'll show you that. I'll quickly explain the code. I have to change these credentials. Control C. Control V. Okay. Now, inside the void setup, you can see we have initialized the UART module to this particular baud rate 9600. Then what we will do, we'll change this default LED pin to pin number 5. And this all these Wi-Fi.begin is related to Wi-Fi connection. So you have to provide the first argument as SSID and second argument as password. So it will ESP8266 or the Tesla board will get connected with the Wi-Fi. So this function will connect that with the Wi-Fi. So this all code is related to Wi-Fi connection. Because of the time barrier, I will just quickly explain everything. So it will the IP address to which the Tesla board is connected, and then using this Firebase.begin object, we are connecting with the Firebase host and the auth using this credential to the Firebase cloud. Now we are writing this to write hi. So whatever data available on the cloud, we are reading that data, LED data. So what I'll do, I will create. So string data is there and we are get string from the Firebase. See, Firebase get string. We are reading this object LED data and we are storing that data into this data variable, and then we are comparing it, and depending upon this data we have received, we are taking some action. In case of digital write, we are writing this particular pin as high, as we have discussed in the LED blinking program using this function, and we are printing serially LED turned on, and vice versa in case of off. So what I will do, I will just create this object on the Firebase, Control C. I will delete everything else. I'll just disconnect the Tesla ID board. And then I will create a JSON object here, Control V, LED data, and in the string format I will add X, Y, Z, some random data. So later we will change that. So we will read this object, means this LED data. That means whatever the data against this object will be available. We are reading that, and depending upon this data, we are taking some action. So like turning on and off this LED and writing data on this pin. So what I will do, I will upload the code. Just select the right port, COM port 5, correct? You can see COM port 5. And then after that, we are writing some random data as well, some number data ranging from 0 to 100 on the Firebase. So we are reading the data and we are writing the data as well. So I'll just upload it. After this, we will end this first session, and after the break, we'll start with the AWS IoT core, which is used in the commercial products and using the standard MQTT protocol. We'll discuss that after the break.
Hello, Uma.
Yes, sir.
There is a break for actually session starts at 10:15 to 11:45.
Okay.
Second session starts at 12 noon.
Okay, sir.
So
Yeah,
there is a break for 10 to 15 minutes.
okay. So it is done. I'll open the serial monitor and I'll turn on my mobile hotspot again. I have turned it on. Now it is connected. So it will start putting some random data, ESP data. You can see. Using this random function, we are sending some numeric values, random numeric values ranging from 0 to 100 against this object on the Firebase. So you can see this. Now what we will do, we want to control. Patil sir, can you turn off your microphone? Hello.
Yeah.
So we want to control the peripherals available on the Tesla board from the cloud. So what I will do, I will connect, first of all, I will connect this GPIO 5 number pin with the LED. First, we will control the LED. So initially it is on, you can see, I hope you see. I'll make it off. So it is capital on and capital off. Make sure that you're writing capital off and capital on. Make it off. See, LED turned off. And now what I will do, I will make it again on. So I will press on and hit enter. Is it glowing? Now what I will do, I'll make it again off. Yes. So you can see the bidirectional data communication is there. We are sending some random data, numeric data to the Firebase. Instead of this random data, it can be a sensor data, it can be serial data, serially available data, it can be anything. And in case of data from the Firebase to the Tesla IoT board, we are controlling using this object. So what I will do, instead of LED, I can connect it with the relay. I'll make it on. I will just keep my microphone close to the relay so everyone can hear the tick sound of relay. Yes. So now we can, suppose if I connect any appliances to relay this right now, we can control it, like we turn it on and off using the Tesla IoT board and cloud platform from anywhere from the world. And this can be done within minutes. Just because a lot of configuration we had to done, so it took so much time. But if you have it with you, you can do it in minutes. You can control anything from anywhere in the world uh, using Tesla IoT board within minutes. So using Tesla IoT board, you can do your any IoT project within minutes, and it is very easy to use, as you have seen. So this is all about this first session. In the next session, we are going to communicate with the AWS IoT core using Tesla IoT board, using the MQTT standard protocol. So thank you all for listening me. Hope you have liked whatever I have just discussed. Thank you. If anyone has any questions, please ask.
So this application also runs on the Android platform.
Uh, which application, sir?
You have shown
Yes,
the various
yes.
control by computer.
Yes. You can connect your Android, because of the time constraint. I have not discussed that part. You can create your Android application, and you can connect it with the AWS IoT, as well as you can connect it with the Firebase. And from Android application, you can control the Tesla board and the peripherals. So using the Android application, you can control your TV, your fan, home automation, do any project. You can read the temperature data, LDR data, Hall effect sensor data, everything you can do with it.
Okay. Thank you.
Okay. So because of the time constraint, I have not included the Android development part, but in the training program, means we conduct the training program for particular boards and different technical topics. In that, we discuss the Android development and how to integrate that with the different cloud platforms, how to integrate all the system and make a simple project. Everything we do in that. Later in the session, I'm going to discuss about this training program.
This project is very best. Can we join Android application with that Arduino C++ embedded C++ code in any using any library? Which library?
I did not understand your question. You mean you want to
Which
connect?
library is used to connect the Android or
See,
Flutter app with the embedded C++?
no. There is no direct communication with the Tesla board and the Android. The communication is done via a mediator. It is Firebase or the AWS IoT. So data communication between Firebase and the Tesla board, or the AWS IoT and the Tesla board is there. And the communication between cloud platform and the Android. These all things are isolated but connected. It is not
Means
interconnected.
first we need to transfer the IoT data from Firebase, and from Firebase we get data from Android or Flutter.
Yes.
Okay, got it. Thank you so much, sir.
Okay.
This project is very useful.
Thank you.
Sir, can this PIC microcontroller can also work on this UV?
Peak, peak controller. Can you interface with this module? Is
Yeah.
it your question? Yes, definitely. We have done it previously. Whatever the different sensor, you can interface with the peak microcontroller. You can get the data. You can send that data using UART towards the Tesla IoT board, and you can then send to the cloud. So you can interface any microcontroller out there with the Tesla IoT board.
Okay. PIC microcontroller cannot talk directly with the cloud.
No, because it does not have any Wi-Fi capabilities.
Oh.
Hello, sir.
Yes.
So myself Meera Subhamya. I belongs from computer background. So I had done these projects on the ESP32 board and ESP8266 board, but I have not fundamental knowledge about it. So can you share your any contact detail or Gmail ID? So if any case any problems will generate, so we can contact with you.
Definitely. At the end of second session, I'm going to discuss or share all the details.
Okay, thank you so much, sir.
Okay. I hope everyone liked the sessions and got some new information. Thank you.
There is a 10 minutes break, participants, and after 10 minutes you have to rejoin.
So second session on which time?
After 10 minutes. Immediately after 10 minutes.
Okay.
And second session is it is on demonstration type. So if possible, you come with your laptop and then the Arduino too. Okay, actually it is a live demonstration, so that you will get exposure. You can get the exposure hands-on practice. So if possible, you come with.
Hello, sir.
Hello.
Sir, is there any exam on today by self?
Exam?
Means any kind of this related to this FDP or
Exam. I will share that message. If there is an exam, I will share.
because in 12 to 6 hours our college will be there. So from college network is very poor. For that I am asking, is there any exam today?
I will share that information.
Okay, please share in WhatsApp group.
Yeah.
Okay, thank you, sir.